Hello everyone, welcome back to MindMatrix YouTube channel. I'm Sachin. So today in this video, I'll be going further with the Bayes theorem based problem. Okay. So I hope you have solved, you have understood the problems and concept we have seen in the last video, which were based on Bayes theorem. I hope the intuition is clear that okay, what exactly do we have? Why exactly do we have Bayes theorem? What is the significance for that? And if you have liked it, I guess you must have given a thumbs up over there in this week in that last video. Okay, and I guess like if you're liking the complete series I'm creating, you must have liked all the videos till now. So let's move further. So in this video I'll be solving a few more questions which I have already shown you in our last session. Okay, so quick intro about myself, you know that. So I'll just skip to the main part. So I'll be talking about these problems now. Okay, so let's solve these. Okay. Yeah. So let's just talk about this problem. So what is being mentioned? Something like this. Consider a communication channel shown below. So we have a communication channel, you can see. So it is something like you can consider it to be some kind of wires you are having. Okay, so you are sending some signal from here and here, and then these are some receiver end at some distant place. Okay, and the thing is the probability, so basically this is not the different ends, these are same. So basically it is like this, that okay, this is like this has been split just to explain the thing. So it is like this, that okay, this is my sender end and this is my receiver end, something like this. So this has been broken down into two parts just to understand what we are sending. Okay, because I may send 0 or I can send 1. So that's why like I have in this video or in this question, this has been split up to show you exactly case by case that how the problem is being emerged, how it is getting created. Okay, so we have a sender point and we have a receiver point. Okay, so now the probability of sending 1, if I send 1, the probability given is p. Okay, because I send it with probability p, and if I send 0, then it will be sent with probability 1 minus p. That is clear, because if I'm sending with p probability, I'm sending 1 with probability p, then for sure like 1 minus the complement part, okay, will be telling me the probability of sending 0, that is 1 minus p, and that is exactly shown that 0 is getting sent by 1 minus p probability, 1 is being shown sent with probability p. That is what I was talking about. Okay, now the point is over here it could be simple if we could have just talked about this, but the next statement makes it more complicated. That's why we have this kind of proper diagram to understand. Now it is said that given that 1 is sent, the probability of receiving 1 is 1 minus eta. If 1 was originally sent from the sender end, then probability of getting a 1 is 1 minus eta. Why is it so? Why 1 is not being received with probability 1? Because there may be some noise in the channel, and because of noise in the channel my signal can fluctuate, so that may convert my 0 to 1 and 1 to 0. That is a possibility. So that means whatever is being sent from my sender end, that may not be necessary that I'll be receiving same thing from the at my receiver end. So there may be some kind of change over there. So the probability of that thing is being mentioned over here. So if 1 was being sent, then I will receive 1 with probability 1 minus eta. I hope this is clear. Okay, that means if I'm sending 1, then I may receive 0 with probability eta, 1 minus eta and eta. Overall, like I can like the probability when I'm sending 1, so I may get 0 or 1, anything. Okay, with probability eta I'll be getting 0, with probability 1 minus eta I'll be getting 1. Similarly, if I'm sending 0, that may also get converted to 1. So if I'm sending 0, then with probability epsilon, okay, with probability epsilon I may get 1, or with probability 1 minus epsilon, I'll be getting 0 only. Okay, so that thing is already mentioned, okay, over here within this line. Now what is being asked? Find the probability that one has been received correctly. Now how do you understand this kind of thing, that what exactly do I need to calculate over here? Probability that one received correctly. One received correctly. What does it mean? So when do you say that you have received one correctly? When you know that you have received one, when you have received one and actually sent was also one. Okay, because see, you are on the receiver end, and if you want to find out whether you have received one correctly or not, so you already know that I have received one. If the send was also one, then I have received it correctly. So what exactly you are looking for? You are looking for kind of probability like this. This is the probability you are looking for. What does this mean? That given you have received one, the probability that one was only sent. Probability is given that one is received. Now you are calculating the probability that one was sent. This is the probability I'm looking for. I'm calculating. Okay. So how can I calculate this kind of probability over here? Oh, okay. What is the difference if I could have, write it this way? What would have been the difference if I do this thing over here? So it means if one is sent, what is the probability of receiving one? So that we already know actually. Okay. If I just talk about this probability, we already know. We don't know about this thing, that if I have received one, what was the probability that one was sent? And this is the exact probability I'm looking for, that one has been correctly received. Okay. And if I talk about this one, what is this probability? That if S is equal to 1, sender has sent 1, receiver has received 1, then what was this probability? It was 1 minus eta. We already know. Okay. So this is the probability I'm looking for. So how can I calculate that? We already know. The Bayes theorem comes to the rescue. Okay. So P of S equals 1 given R equals 1 can be calculated as probability of R equals 1 given S equals 1 into probability of S equals 1. Divide by what? The same quantity over here plus probability that R, the received one is 1, but the sent one was 0. This is what we do normally in Bayes theorem. Okay. Or like whatever is the denominator, I just used law of total probability to decompose it further. So either 0 was sent or 1 was sent. So I have broken down it into two parts. So what is going to be this thing? So if I have sent, if I sent 1, then probability of receiving 1 was 1 minus eta. So 1 minus eta into what was the probability of sending 1? The 1 was sent with probability P. What will be the values in the denominator? So this will repeat 1 minus eta into P plus what else? What is the probability of receiving 1 if 0 was sent? If 0 was sent, what was the probability of receiving 1? It was epsilon. It was epsilon. Into what is the probability of sending 0? The probability of sending 0 is 1 minus P. I hope the idea is clear. So this is the final expression we are having. This is the final expression we are having. I hope this is clear. A basic question. We have got to know that what exactly we are looking. If you can find out what exactly we are looking for, and if you can, write it properly to find out the values you want, then you will be able to solve the problem very easily. But if you don't know, okay, what exactly you are looking for, how should I write it, then you may, struggle to get the correct answer. I hope the idea is clear. Okay, so let's move further to the next question. Okay, this is a really interesting question, a very good question. It needs a kind of good, understanding to be able to solve this problem. So what is given over here is you know that a certain letter is equally likely to be in any of the three folders. Let's suppose you have folders. Okay, let me just write. Okay, let's suppose this is folder 1, this is folder 2, and this is folder 3. Okay, and there is this letter which can be in any of these, which can be in any of these. It can be in any of these. Okay, and the probability is equally likely, the scenario is equally likely. That means the letter can be in any of these with probability 1 by 3, with probability 1 by 3. So it's like I can write it like this. Okay, so let me just write something like this. Pf1 is equal to L is 1 by 3. What do I mean by F1 equals N? I'm talking about the event that folder 1 has the letter L. L means letter I'm talking about. So folder 1 has letter. The probability is 1 by 3. So probability, this thing also can write it as 1 by 3, and same goes for probability of F3 equals L. Okay. So up to this it must be clear. Now let alpha I be the probability that you will find your letter upon making a quick examination of folder I if the letter is in fact in the folder I, and I value is 1, 2, 3. So what does this thing mean? It means that this is being told to me that F1, if F1 has the L, if F1 has the L, then upon examination, okay, so it is like something like this I'm talking about. F1 is already L, that means F1 has the letter, and then I'm examining, okay, and then I'm examining, okay. So probability of finding the letter in this case is alpha 1, something like this. Okay, so my E basically refers to examining what does this mean? Examining folder 1. Okay, so let me just write it properly. The idea may not be clear the way I'm writing it. Let me just improve it a bit. Okay, yes, so it should be something like this. Even given F1 equals L. Yeah, now this is better. So हमें पता है, we know that okay, F1 has a letter. If F1 has a letter, then on examining I will find, examining on checking the letter, sorry, on checking my folder I will find my letter. That probability is alpha 1. That probability is alpha 1. So let's make it this thing. E1. Okay, getting letter on examining folder 1. Okay, and let me just write E1 dash. That means not getting letter, not getting letter on examining folder 1. Examining folder 1. I guess this is clear. Like, let me just repeat if you are not able to read what I have written over here. So E1 means getting letter on examining folder 1. If I'm checking my folder 1, then what is the probability? So even is the event I'm talking about. Event when I'm getting the letter on examining folder 1. And even dash means, this is even dash. This means not getting the letter on examining my folder 1. So this is being told that okay, the probability of getting the letter on examining folder 1 if it had the letter is alpha 1. So that means, let me just write a few more things over here. That means what will be this thing? Just tell me this thing. Just try thinking about this. What must be this value? and what must be this value. Okay, because this will make it clear whether you have understood it or not. Okay, whether you have understood it or not. So this thing is probability of getting letter on examining folder 2. This even, the subscript represented the folder I'm talking about. So E2 event means getting letter on examining folder 2. So what will be the probability of, let me just keep it F1 only. Yeah, F1. It has to be F1. What is the probability of finding letter on examining folder 2 when letter was in folder 1? So it is 0. Is 0 because I'm definitely looking in the wrong folder. So that probability has to be 0. I hope this thing is clear. Okay. Okay, if I just talk about this thing, that okay, if F1 has my letter, then what is the probability of not getting my letter? It is 1 minus alpha 1. It is 1 minus alpha 1, because I know in this particular folder I have the letter and I'm checking the same folder. Then probability of not getting my letter is 1 minus alpha 1, but of getting is alpha 1. And if my letter is in some other folder and I'm checking, some other one, then probability of finding is 0. And if I just talk about one more probability, something like this, probability of E2 dash given F1 is equal to L, this is 1. Why so? Why so? E2 dash means not getting letter on examining folder 2, because you have letter in your folder 1, so definitely you will not be getting that. So the probability of that is 1. I hope all these values are clear. What is this, what is this, what is this, what is this? The way I have written it must be clear. Okay, so now what exactly do we need to find? Let's just check further. So this is very important, because understanding problem over here is very important. So suppose you look in folder 1 and do not find the letter. As I mentioned you, okay, letter may be present in a folder, but when I check, I may not find that. That's why we had a probability associated with that, alpha 1 and 1 minus alpha 1. Okay, so suppose I looked for the folder 1 and I did not find the letter. Now, considering this knowledge, I have done that. I did not find. What is the probability that letter is still present in that? That letter actually is present in folder 1. So what is the value I'm looking for? The value I'm looking for is F1 is equal to L. That folder 1 has the letter, but what knowledge now I'm having, that I have already checked. I have already checked. What I have checked? I have checked even and I did not find the letter. I did not find the letter. I hope the idea is clear. I hope idea is clear. Okay. This is very important. This is very important. So as I have not got the letter, so what was the even dash means? On checking even, not getting your letter, and I have not got the letter, and we did not find the letter. This is the probability I'm looking for. This is the probability I'm finding out. So what will be this one? It will be, again, you will be using Bayes theorem, because this you cannot find directly, but the other parts, the other conditional probabilities. What is that? Probability of even dash given F1 equals L into probability of F1 equals L, divide by, you'll have the same quantity, plus probability of E1 dash F2 equals L, because letter can be in 1, 2 or 3, third folder, second folder and first folder. Probability of, sorry, I have to multiply it with probability of F2 equals L, plus within this denominator I'm doing this, probability of E1 dash F3 equals L. Okay, and into probability of F3 equals L. Let me just tell you what exactly this means. This is the probability of not finding the letter in first folder when it was still present. What is this? This is the probability of letter being present in folder 1. We have already seen this. Okay, we have already seen this. Now what does this mean? This means that probability of not finding your letter on examining folder 1, even dash means you are examining folder 1 and not getting the letter, given that letter was in folder 2. If letter was in folder 2 and you are checking folder 1, then the probability of getting, not getting the letter is 1. We have already seen this kind of thing. We have already seen that if you are, you may be getting confused that f1 is there but f2 is here, and this is e2 dash e1 dash. The concept is same. What does this mean? Let me just repeat over here. This means your letter is in folder 2, but you are examining 1 and then not getting the letter. Then what is that probability? It is 1, because you are checking the wrong folder. So not getting probability is 1. Okay. And then this is the probability that f2 has the letter. Okay. And that you already know, like f2, f1 and f3 both may have, like, letter equiprobably. And again, similarly, you can have this case when you are calculating the probability of not getting the letter on examining folder 1, when in fact your letter was in F3. So same as in this case. So again, this probability will be 1 because you are checking the wrong folder, and then this thing. So what would be the values you'll be getting? So let me just write it over here. So this value, this particular value is not getting. This is 1 minus alpha 1. 1 minus alpha 1 into what is the probability of, a letter being in F1, that is 1 by 3. So that same thing will come over here. Now for this part, you already know this probability is 1. The probability of not finding a letter if you are, looking in the wrong folder is 1, into probability of getting, not getting, probability of letter being present in the same folder is 1 by 3 plus 1 into 1 by 3. This 1 by 3 gets cancelled. That is common for all. Basically, you can just take 1 by 3 common over here and then, cut it with the numerators 1 by 3. So what do you get? You get 1 minus alpha 1 in numerator upon, so this is 1 minus alpha 1 plus 1 value would be remaining over here, 1 over here, 1 plus 1 2, 2 plus 1 3, 3 minus alpha. So this is the exact answer you are having. This is the probability you are having. Probability that the letter is in folder 1. Okay, the probability that the letter is in folder 1 when you have, already checked folder 1 and you did not find. This is the probability. I guess the idea is clear. The question was good. Okay, how you can understand this? There was lot of understanding within this question. Okay, so now let's move on to the next question. Let's talk about this thing. Again, a very good question. Let's see. So there are 3 chests, each having 2 drawers. So let me just show you what kind of chest we're talking about. So this is the kind of, like a small kind of, what should I say? A kind of tables we generally have on the side of our beds. So a kind of, small table we are having, okay, over which you put your phones and, lamp you're having, and then there are drawers over here, something like this to pull these drawers. Okay, so this is one chest. So there are 3 such chests, each having 2 drawers, This is the handle I'm just making, okay, just to pull out this drawer. So you're having 3 chests. So let me just mark it as CH1, CH2 and CH3. Okay, now chest 1 has a gold coin in each of the drawer. Chest 1 has a gold coin in each of the drawer. That means this also has gold coin, this also has gold coin. Okay, so now we are sure, okay, in both of these you are having gold coin, while chest 2 has a silver coin in each drawer. So that means silver coin in this one, silver coin in this one, on both the drawers of chest 2. Chest 3 has a gold coin in one drawer and a silver coin in another drawer. Now we don't know which drawer we are talking about. So I cannot write S, G or GS. I cannot write that because I don't know which drawer is containing. I just know one is having silver, one is having gold. So what I'll do, I'll just write it this way, that okay, gold and silver is present in, these drawers. Gold and silver is there. One containing gold, the other containing silver. Okay, that I know. So now what is the problem? Chest is chosen at random. Any chest is chosen at random. So you can find out the probability first. The probability of choosing one chest is going to be same as probability of choosing chest 2, same as probability of choosing chest 3. Choosing chest 3. That is 1 by 3. I hope this point is clear. Now a chest is chosen at random and one of its draw are chosen at random. First we choose a chest at random, and then once we picked up the chest, we picked up the drawer randomly, that okay, any drawer I'm picking, either at first or second, any drawer. Okay, so then when I opened it, it is found to contain gold coin. It is found to contain gold coin. Okay, so let me just mark these kind of things. So this is, let's say, D1, this is D2, this is D1, this is D2, this is D1, this is D2. Okay, because we will be needing some kind of notation to understand. So I know that the drawer I opened first, that may not be D1. D1 means I'm talking about first drawer of chest. So the drawer I have pulled up, the drawer I have checked up may not be the first drawer or may not be the second drawer. So I don't know. So I'll just write DI. I'll just write DI. Okay. First drawer drawn. Okay. Or picked up. Drawn or picked up. That means I'm saying that DI was the first draw I picked up or drawn, and after that also I'm talking about the other drawer. So let's suppose di plus 1, di plus 1 is the other drawer. Now this I can be 1 or 2, and correspondingly if I is 1, then my I plus 1, don't get, don't go by this kind of notation that okay, if I is 1, then I plus 1 has to be 2, because I may be 2, then I plus 1 would be 1. I'm not saying that it will be adding exactly. I have just taken it as a notation that the first drawn is I, the second number drawn is I plus 1. Okay, now that can be anyone, 1 2 or 2 1, any order can be there. Other drawer. Okay, so I hope the idea and the notation till this point is clear, and I know that di was G. I know that the drawer I drawn first had a gold coin. So I'll write di equals G as the event that the first drawer I drawn had a gold coin. Now di can be D1 or D2 of CH1, CH2 or CH3. Like completely randomly. I'm not sure what what is the chest from which I have picked up this draw. Okay. So now di equals G because the gold coin is present in that particular drawer which was picked up. Now what is the probability that the other drawer has a gold coin? Now what I'm looking for is, now I guess the notation must be clear. The notation is, what I'm looking for is this thing. This is the exactly stuff I'm looking for. Probability that my other drawer has a gold coin given the first drawer I picked up had a gold coin. Now this is the probability I'm looking for. Okay, this is the exactly what should I say, the probability I'm looking for. Now if you don't have the good concept, you may go into some kind of wrong direction. So let me just first of all be clear over here. So you don't know this kind of calculation. Do you know this thing? Do you know this thing? Just tell me this thing. Okay, if my second drawer has a gold coin, what is the probability of getting a gold in the first draw? So again, this is kind of same thing I'm asking, yes or no? Okay. So I won't be using kind of Bayes theorem over here. This question is exactly based on conditional probability, to be honest. Okay. But it uses the concept of total probability, which you'll see right now. So just to calculate this, let me just write over here the formula you'll be needing. So it's like P of di plus 1 equals G, given di equals G is equal to probability that di equals G and di plus 1 equals G. The normal formula which we have when we want to calculate conditional probability, divide by probability that my first drawer, whatever it was, it may be the second drawer of a chest or first drawer of a chest, this is going to be my final answer. This is going to be my final answer. The probability that both the chests are, sorry, both the drawers are containing gold coin, divided by, gold in my first drawer. Okay, so this is the probability I'm looking for. Now how I can calculate that? So let me just represent this thing with the help of one thing. So how can I write this kind of thing? Let me just represent it by event B, and let me just represent it with event O. Now what is B and O represent? B means gold in both, gold in both, and O means gold in one, because I don't know like which drawer I have picked up. It can be the first drawer or the second drawer. I don't know exactly the sequence, the order. So I'm just talking about the fact that okay, di equals G and di plus 1, both, this is the intersection I'm talking about. So that means both drawer must have gold coin. So I will denote it by B event, and di equals G means I don't know whether it is D1 or D2. So I am just writing it as O. That means probability of getting gold in one of the your draw. Okay, so something like this I have to mention. Probability of B upon probability of O I need to calculate. How can I do that? So I can just use the total probability law over here and total probability law over here. What do you get? It will be probability of B given CH1 into probability of CH1 plus probability of given. So this is not the Bayes theorem I'm using over here. This is the total probability law in the numerator, and then in the denominator as well I'll be doing. Okay, so chest 2 into probability of chest 2. So let me just erase this complete part. You are getting, because I'm going very slow. Going very slow. So let me just write that complete expression over here again. Okay. So PB by PO I'm exactly looking for. What I'm looking for is PB probability of event B by probability of event O. What is that? So this is probability of B given the chest chosen was chest 1, and then probability of chest 1 plus P of B chest 2, probability of chest 2 plus probability of both gold coin, given that the chest chosen was 3, then probability of choosing chest 3, divide by the same stuff, P of O CH1, probability of CH1. So I have mentioned it already. This is not the Bayes theorem we are using over here. This is law of total probability we are using over here. Sorry, this has to be 2. O CH3, probability of CH3. So just tell me what will be the values you'll be having. So see, if you know the chest 1 was chosen, what is the probability that both the drawers contain gold coin, the probability is 1, because we know both the drawer contains gold coin. So if just one was there, if just one was chosen, so the probability was 1. What is the probability of choosing just one? That is 1 by 3. 1 by 3, we have already discussed it. What is the probability of getting gold coin in both? If just 2 was chosen, what is the probability of getting gold in both? The probability is 0, because we know in chess 2 there are silver coins in both, no gold coins. Okay, so it's 0 into 1 by 3 plus, what is the probability of getting both, gold in both the coins if chess 3 was chosen? So again the probability is 0, because I know in one there is gold, but in the another one there is silver. So I'm looking for gold in both, so that is 0. That is 0, because I know if chess 3 is there, I won't be having gold in both the drawers. Okay, so that is, again, I guess all the values I have written properly, just to make you understand exactly how we are doing it. Okay, so now what is this value? Probability of getting one gold coin when you are having chest 1, when you chose chest 1, so that is again 1. Probability of choosing this is 1 by 3 plus probability of getting a gold coin in one of the chests provided you chose chest 2. So as I know over here, again this is once both the silvers are there, so probability is 0 into 1 by 3 plus probability of getting one gold coin given chest 3 is chosen. So yeah, I know one of them contains the gold coin. So what is the probability of getting a gold coin if I have chosen chest 3? That is 1 by 2. Okay, into 1 by 3. I hope every value is clear. So let me tell you why this is 1 by 3, 1 by 2, because I know I have picked up the chest 3. Now what is the probability of getting one gold coin? Because any drawer can be there, it can be D1 or D2, so there can be G in one or there can be S in one. Okay, so the probability of getting a gold coin is 1 by 2, because the other possibility is getting silver. So what is this value? So I guess because 1 by 3 is common to all, this can be cut down. What is this? 1 plus 0 plus 0, that is 1 in the numerator. In the denominator, you'll be having 1 plus 0 plus 1 by 2. 1 plus 1 by 2 is 3 by 2, which is nothing but 2 by 3. So 2 by 3 is the answer. 2 by 3 is the answer. I hope the idea is clear how we have calculated it. I hope the idea is exactly clear how we have calculated it over here. Okay, so let's move further. So I'll just solve this problem again in a very simple manner now. Okay, very simple manner. I hope this complete idea is clear, that how we are writing each of the thing and then calculating each of the values present. So now let me just give you this thing. So you already got the intuition that okay, what were the chests, what were the drawers. So let me just talk about a event, which means you are getting what? Gold coin in the first drawer you have picked up. What I'm telling you is a event means you are getting gold coin in the first drawer you have picked up. So that can be, so you remember chest 1, both the gold coins were present. Okay, so this is A. Now why I have not written chest 2? Because chest 2 was having only silver coins in both. Okay, and chest 3 was having drawer, like only gold coin was present in one of them. And let's suppose, because okay, this is my assumption, that let's suppose that okay, from ch1, if the picked up was d1, or this could be the one or this could be the one. So this is a scenario we have just created right now for the understanding. Okay, that what was the drawer drawn picked up, what was the drawer picked up, and then we had a gold coin. Okay, so let's suppose A was this kind of thing. Okay, now the second drawer which was picked up, second drawer, when I am going to have this thing that gold coin is there in the second one. So if D1 was the drawer which was drawn for the first time, then I can have gold coin in the second one. If D2 was the first, then I can have a gold coin in D1, and then similarly CH3 D2. Let me just make it clear what exactly does this thing mean. So this thing means CH1, CH2, CH3, but wherever it is present, it means the chest which was there, which was chosen, and then D1, D2 or D3, it means the drawer which were chosen, drawers which were chosen. Okay, and as I mentioned, I have got the gold coin. So this is what I'm talking about, that gold coin. Okay, this is A event represent my gold coin, and the D1, D2, D1 is which is mentioned over here. It means the drawer I picked up, the drawer I picked up. Okay, so if D1 was the drawer which was picked up for the first time, so definitely corresponding to that I will be having D2, because the other drawer would be picked up. See over here, the chest is chosen at random, one of its drawer was chosen at random, found a gold coin. What is the property? That other drawer. So if D1 was chosen, then other drawer is D2. If D2 was my first drawer, then other drawer becomes D1. So similarly over here, if D1 was the first drawer which was chosen, then D2 becomes my other drawer over here. Okay, so I hope this thing is clear. Now A represents these containing gold coin, and B means these containing gold coins. A even represents that, okay, that my gold coin is present in these which were picked up first. Okay, and B represents gold coin when these were picked. Now what do we need to calculate? We need to calculate P of B given A. This is the stuff. So P of B, basically intersection, and P of A. What is the intersection you'll be having? The intersection of both of these would be, like CH1 D1 and CH2 D2 are the common elements. So you'll get 2. So what is the size of that? 2 only. Okay, so that is going to be 2, because you already know that probability actually is nothing but something like this. We have already seen the size of our event set divided by size of our sample set. So size of my, if I talk about P of AB, so that is going to be 2 upon the total cases possible. So let me just write it this way so that you don't get uncomfortable. And P of A is going to be 3 upon this thing. Okay, so what do you get? 2 by 3 again. You get 2 by 3 again. Okay, I hope the idea is clear. So let me just repeat this once again, this way of solving, that A is representing my first draw, Why I have not written CH2 over here? Because I know that I have got a gold coin, and within CH2 there was no gold coin. So I'm just writing the possible cases for my gold coin, and that too in first draw. I'm talking about first draw. So if I write CH1 D1, CH1 D2, CH3 D2, sorry, CH3 D1, then the second draw will become from the same chest. So if CH1 D1 was the first draw, then the other draw would be CH1 D2. If CH1 D2 was the first draw, then CH1 D1 will become my other draw. If CH3 D1 was my first draw, then CH3 D2 will become my second draw. Okay, so that's how I have written these. And now A was mentioning that I had a gold coin in these, and B is the event, because that was being asked that other drawer also has a gold coin. So B represents another event where I may have a gold coin. So to calculate P of B given A to have a gold coin, you can see the formula and what way we have proceeded, and we are getting the same answer over here. I hope the idea is clear. Okay, so this was problem 3. I guess, yeah, it's already 44 minutes. So now we are having the next problem. Let's see that. So yeah, this is the Monty Hall problem, the standard problem over here, very interesting. Okay, so I'll just give you in brief what exactly is the problem, and then we'll solve this problem. So the problem is something like this. We have three doors. We have three doors. Okay, and we can have, we will be having car behind any of these doors. We will be having car behind any one of these doors. Any one of these doors. And behind the other two doors, I'll be having a goat. So it can be something like this: GCG, or CGG, or something like, GGC. What does it mean? G means goat, C means car. So there are these kind of possibilities that car can be behind any of these three doors, and behind other two doors I'll be having a goat. So this is the problem. Now you are playing this kind of game where a host asks you that you need to guess which door has car behind it. You have to make a guess, and suppose you made a guess, you chose D1. Let's suppose you chose D1. You chose D1 door. Okay. Now, as you have chosen door D1, what does host do? Host will show you, he will open one of the other two doors. Either he will open D2 or he will open D3 and show that there is goat behind it. He will open one of the door D2 or D3, and he shows that there is a goat behind that. Now, because he has shown you one of the door having a goat, he will ask you, would you like to change your opinion? Would you like to change the door you are looking for behind which the car can be there? And if you guess the correct, if you change, let's suppose from D1 you pick up D3. So let me just write this. Initially you picked up D1, host opened D2. Host opened D2. Okay, let's suppose this thing. Then he will ask you whether you would like to, keep your opinion with D1, or you would like to change it to D3. That you want to guess D1 only, you want to go by your first opinion, which was D1 door only, or you want to change it to D3 door, because whatever choice he will be picking up or sticking up with, that, according to that, he may win or lose a car. If D1 has a car and if he stick to that, he will win the car. But if D3 has a car and he stick with door 1, then he will lose the car. Similarly, if D3 has a car and he change his opinion to, make it that D3 has a car, then he will win the car. I hope the idea is clear, that if he changes his opinion and that door has a car, then he will win it, otherwise he won't. So just to win the car, we have to find out whether he should switch the opinion or not. He should switch the door or not. So let me just write in brief. So let's suppose we have to fix the values over here. So let's suppose D1 was the door you picked up, D2 is the door opened. Now you have two choice, either to stick to D1 or to D3. Now the idea and the question is whether you should switch the opinion or not. Okay, because he has given you some extra information. He has shown you D2 door. Then should you be switching your choice for getting a car or not? That is the idea over here. So the thing is, it depends upon the probability. See how probability is coming over here. So the thing is, let me just write this thing over here. So let me just write a few more things. This will make it clearer. So P of C1 means this is 1 by 3. Okay, let me just write all the events first. So I hope everything is clear over here. I'll just erase everything so that I can write from scratch what all the events are all about over here. Okay, so let me just tell you, C1 is the event that door 1 has car behind it. Okay, I'll just write all the cases right now. C2 is door 2 has car behind it. C3, you know, like door 3 has car behind it. Okay. Now, if I am writing something like this, O equals D1 or O equals D2 or O equals D3, it means D1 or D2 or D3, like in the same order I'm talking about, has been opened by host, has been opened, has been shown, has been opened by host. Okay. Okay. Now this is the thing. And yeah, so these are the events now I'm talking about. So now the thing is, now let's just stick to the points. So as a user, as a contestant, let's suppose you have picked up D1. You have picked up D1 because we have to fix some values over here, then only we can talk about that. So if you have picked up D1 and let's suppose O equals D2, O equals D2, then you will calculate something like this. C1 given D2 and P of C3 given, sorry, oh, there are too many space limitation is there. Yeah, C1 when D2 was opened and C3 when D2 was opened. So you just calculate these two probabilities. Whichever is highest, you pick that particular door. If probability of getting a car behind first door is higher, given that D2 door was opened, then you will keep your opinion with door 1 only. If probability of getting a car behind C3 is higher, given that door opened was D2, then you will pick up that. Now we will calculate this probability and we will get the answer that okay, shall we switch the opinion or shall we keep that same thing? Because over here at this point there is an extra information given to us. A naive person, very innocent person who does not have idea about probability and some basic knowledge, he would be finding it okay, it is the still same case that okay, like there is no extra advantage I have got. But the thing is, when host showed you one of the door, he has given you some information. What is that? You'll realize it now. What is that? You'll realize it now. So I hope this C1, C2, C3, O equals this thing, all these idea is clear. And I have mentioned that D1 was the first door. You can pick it in any order. If you say that okay, we have picked up D3 and the door shown was D1, you can also go in the same fashion and you'll get the answers in the same way. Okay, so now I will calculate these probabilities. See, how do I calculate? So I'll just erase these things. Okay, and this is very interesting problem. See, now I will calculate. So probability, you just tell me you want to calculate this thing, O equals D2. This will be probability that door D2 will be opened if C1 was the case. If C1 means door 1 has the car behind it, into probability of C1 divided by this same quantity plus probability of opening D2 given C2, that means car, door 2 has the car behind it, plus probability O is equal to D2 given C3, that means door 3 has a car behind it, into probability of C3. What is this value you will get? See, if you know D1 was the door picked up first and it has a car behind it, so what is the probability that D2 door will be opened? What is the probability that D2 door will be opened? So it is like this thing, that okay, you know there is a car behind it and there are a goat behind these two. There are goat behind these two. This is D1, this is D2, this is D3. So I'm saying if C1, if you know car is behind door 1, then what is the probability that he will open door D2? The probability is 1 by 2, because we know whenever he will be opening a door, he will always be showing a goat. He will not be showing car for sure. He will only be showing goat. So he has to pick a door which has a goat behind it. So both the door has goat behind it. So probability of choosing D2 in that case is 1 by 2. Probability of choosing D2 door when you know the car is behind door 1 is 1 by 2. Now, what is the probability that C1 is there? That means what is the probability of having a car behind door 1? That is 1 by 3, because the case is equally likely. Car can be behind any of these doors. Okay. So P of C1 as well as P of C2 and P of C3 is 1 by 3. Divided by same thing, same quantity, plus. Now, what is this? Probability of opening door D2 when you know the car is behind C2. Just tell me, if car is behind this door, if car is behind this door, then what is the probability that he will open this door? The probability is 0. He won't be opening. Let's suppose you have picked up door D1 and it had a goat behind him. The host knows it. And he opens door D2 and it had a car behind it. Will he be opening? The answer is no. He won't be opening it for sure. The probability is 0. And again, probability of C2 is 1 by 3. Plus, you have chosen D1. You have chosen D1 and you know that car is behind the third door. What is the probability that he will open this one? The probability is 1. Why? Because he cannot open D1. Because the door you have already chosen, he cannot open that. And D3, if I talk about, we are saying that, okay, C3 is the case. That means door 3 has a car behind it. So he cannot open this. He cannot open the door with the car behind it. He has to open this only. And the probability of opening this one is 1 in that case. 1. And then probability of C3 is. So now if you just realize what will be the values you will be getting, the value over here will be, this is 1 by 2, over here it will be 1 by 2 plus 1 by plus 1. So this is 3 by 2. So 1 by 2 by 3 by 2 is 1 by 3. So if you stick to your choice, when D2 door was open, the probability of winning car, because you have chosen D1 only, is 1 by 3. Now if you do the same thing, probability of, because see, he has opened D2 door, so you won't be definitely choosing D2 door in that case. So you'll be talking about third door. The probability of getting a car behind third door if D2 door was opened in this complete scenario. So what will be that? So like denominator will be same, but this value will be coming in the numerator. And what was this value? 1 into 1 by 3. So let me just write. So instead of this 1 by 2, there will be 1. Instead of this 1 by 2, there will be 1. So I will be having 1 upon whatever was the sum over here. What was the sum? 1 by 2 plus 1, which was 3 by 2, which becomes 2 by 3. You can just calculate it, okay? Just because this part would be coming in the numerator this time. So what was this? 1 into 1 by 3. And I know 1 by 3 will be cancelled because that would be common for all. So 1 would be left in the numerator and denominator would be sum of all. Sum of this, whatever was there. So it was, I guess, 3 by 2. So this is the. So the thing is, if you chose door 1 initially and host opens door D2, then probability of having a car behind door 3 is higher. That is 66.66%. You can see. And probability of having a car behind the door you have already chosen is 33.33%. That means 1 by 3. Okay. So this is the exact case. So you must be switching the door. You must be switching the door. Okay. And now if I tell you that okay, you need not to do this many things. You can directly find out the answer. What is the way of that? The intuition. Let me just tell you about the intuition. I hope the idea is clear. The problem was you have door 1, 2, 3, and you will be picking up one door, and host will open a door which will be having a goat behind it, and then he will ask you whether you would like to change the door you have chosen or not. Okay, now just because you have got an extra information because he changed the door, should you be changing it? Because then there will be a probability associated with the door having a car behind it. So if you do not change, the probability of you winning a car is 33%, which is like 1 by 3. And if you change the door, if you change or switch your choice, then probability of you winning a car is 66%. That means like 2 by 3. I hope this thing is clear. Now let me just give you a brief idea how you could do that just on the basis of intuition. I'll just remove everything. See beautifully how you could understand this. Very, like, when I just thought about it for the first time, I was like very much fascinated. We need not do this kind of stuff over here. So let's suppose this is D1, this is D2, this is D3. Okay. So you know the rules. You are a smart guy. You are a smart guy. You know the rules. You will be picking up a door. The host will show you some door which will be having a goat behind it. Okay. I hope the idea is clear. You will know the rules. What will be happening? You will pick up a door and host will show you other two doors. From the other two doors, he will show you one of the door which will be having goat behind it. Now, if you want to know you should be changing or not. So the idea is simple. So if you do not want to change, what is the chance of winning? If you don't want to change. So if you don't want to change, so it's like if you don't want to change, you want to stick to your choice. So initially only you have decided that the car is behind this door. Yes or no? Because you won't be changing your choice. You know that the door I'll be picking up is the final one for me. So what is the winning car in that case? Because you'll be picking up only one door which may have a car behind it. What is that probability of having a car behind that? That is 1 by 3 only. Having a car behind one of these doors is 1 by 3 only. But if I say that you will be switching the choice, you will switch. You will switch. Then what is the probability of winning? Then what is the choice? Probability of winning. You will change. The first thing was you won't change. So whatever you have picked up first, you will stick to that. So chance of winning in that case is 1 by 3 because initially you'll be picking up one from the 3. So the chance is 1 by 3, which is 33%. But if I say that you will be changing for sure. So if you will be changing for sure, in that case, that host will show you some door which will be having goat behind it. So it's like something like this. See it carefully. You have a doubt that these two can have a car. I don't know which among these, but I have a doubt that behind one of these two only there is car. What I have figured out is I know behind one of these only there is a car. I'm not able to judge. Okay, one option I have eliminated directly, that okay, D3 may not have a car. I'm having confusion between D1 and D2 just because I know I will be getting a chance to switch. So I will be having this thing that okay, I have a doubt that D1 or D2 may have a car. So what is the probability of me thinking that okay, which two doors can have a car? What is the probability of choosing two doors which may have a car? It is 2 by 3. Now how does this thing help over here? The thing, how does this help is I am sure that okay, behind D1 or D2 there is car. So I will pick D3. Why so? Because when I will pick D3, the host will cancel one of these doors because he'll show it and there will be code behind it. In that case, I will be sure, okay, that I would like to go with D2 because I would be changing. I know I will change my decision. Okay, what did I say? Let me just repeat over here. I said that, okay, choosing, two door where I feel the car can be there. What is the probability? 2 by 3. Okay. Now chance of me being winning is 2 by 3. How is that? So if I know D1 and D2 may have a car, I won't be choosing any of these door. I will be picking D3 initially. I will say, okay, I would like to go with D3. Now, when I have chosen D3 door, I know the host will open either D1 or D2 for sure. And I had a confusion between D1 and D2 only. So then, because I knew I will change my decision, I am clear that which one to go with. That's it. So that's the way I have got 2 by 3 chance of winning if I know I will change my decision. So 66% chances if I change, and if I know, how am I going to do that? Okay. So I hope the idea is clear. You may have liked this problem. This is not from the examination point of view, but just to make you understand, it was a good problem to discuss. So that's why I have discussed it. Okay. So if you like this session, if you like this problem, do give this video a thumbs up. Okay. Share it with your friends. Again, comment down any of your perspective, your view, your doubt, your question, anything. Just comment down below, and don't forget to subscribe our channel. Okay. So I hope you are really liking this series. So these are the references I'm using, and you can join our WhatsApp channel by this. You can write it, or it would be present in the description of this video as well. You can go and join our WhatsApp channel through that as well, and you can scan this a QR code to join a Telegram group where you can ask your doubts, and you can follow us on Instagram by scanning this Instagram QR. Okay. So that was all, guys. Thank you for watching this video. I hope you have enjoyed it. Take care, guys. See you guys in the next session.